Yes, welcome back to the next lecture on the series of quadratic functions and equations. And now I will take up two questions, right, from the Pure Maths Cambridge curriculum book, Pure Maths 1. And we will look at the problems related to the first two lectures that I have recorded, right? You can go through those concepts, look at my first two lectures on how to complete the squares in the case of a quadratic function and how to write the coordinates of the vertex and therefore point out whether the coordinate is a maxima or a minima point. So I will take two questions to highlight that and to practice on the concept that you've done. See, I always say maths is by practice. So as many questions as you can do, it will be, always good for you to see that the concept is well, imbibed and learned. So let's do this question number 3 and 4. This is from the exercise 1F of the pure book number 1 of the Cambridge curriculum, right? This one. And we are going to use the idea that I already have covered. Let's do question number 3 first. Express 7 plus 5x minus x squared in the form where a and b are constants, and then find the coordinates of the turning point of the vertex of the curve and stating whether it's a maximum or a minima point, and then the other one. So let's look at the 7 plus 5x minus x squared. So we'll do this now. This is question number 1. So it's given as y is equal to 7 plus 5x minus, and we have to write in the form a minus x plus b whole square. Right? So how do we do that? So it means that I have to first always, whenever any quadratic function is written, first write the x squared term, then try to write the x term if it is there, and then the constant. So the leading term is called the x squared term, and it should be written at the very first term should be the leading term. And then you can have the x term and the constant term. That is the standard format of a quadratic functions. Now it's very easy. We have x square coefficient has to be made plus 1. It is not plus 1 here, it is minus 1. So what I'll do is I'll factor out minus 1. And then I will be left with x squared, and 5x therefore will become minus 5x. I always keep the constant outside. Don't take the constant within the brackets. Keep it outside, and now we can easily make it a completely the square form, x squared minus 5x. So the idea is x minus, divide this 5 by 2. And then write minus of, again, 5 by 2 whole square. That's what we did in the first lecture. So we have now minus x minus 5 by 2 whole square. When I multiply this minus with minus, it will become plus. 5 by 2 whole square is 25 over 4 plus 7. So we have minus of x minus 5 by 2 whole square plus 7 times 4 is 28. 28 plus 25 is going to be 53 over 4. Right. So can we put it in the form that is asking? He's asking a minus. So let us put 53 by 4 in the front and then write it like this. So this is the completed the square form that we have got. And this is in the form that is asking a minus x plus b whole square, where a and b are constants. Right. So what is a here and what is b? So a here is 53 by 4 and b is minus 5 by 2. Look at the question. He's asking x plus b whole square, and we got x minus 5 by 2 whole square. So b is minus 5 by 2. Isn't it? Now, what is the coordinates of the vertex? Coordinates of the vertex from here would be 5 by 2, isn't it? And 53 by 4. X coordinate is 5 by 2. If you compare with the form that we did, a times x minus h whole square plus k. So here h is 5 by 2 and k is 53 by 4. And it because the coefficient of the x square is negative, which gives me here minus 1. That means a is negative here. A is minus 1, which is less than 0. This is going to be a parabola like this, right? And therefore, these coordinates of the turning point, also called the turning points, give me a point of maximum. So the maximum value of the function is 53 by 4. And it happens at x equal to 5 by 2. Right? That's what is the idea that we have covered in the first two lectures. Find the coordinates of the turning point, stating whether it's maximum or a minimum point. So it's a maximum point. The x coordinate of the maximum point is 5 by 2, and the maximum value of the function is 53 by 4. And just to show you the graph or the parabola, how it will look like, it's going to be like this. Isn't it? So we take now the second question also, where we are given a different kind of function now. Express 2x squared plus 9x plus 4 in form this. And then write down the coordinates of the vertex, state whether it's a maximum or minimum. 2x squared plus 9x plus 4. So we take it now. 2x squared plus 9x plus 4. Again, the coefficient of x squared is not 1. So I'm going to factor out 2. What will be left will be 9x over 2. Now, what we do is, we again divide this 9 by 2 with another 2, which is 9 by 4. That's the idea we did. And minus square of 9 by 4. That's what we said in the very first lecture of how to make the completed square form. So 9 by 4 whole square is 81 over 16. When I multiply with 2, I'll get 91 over 8. Is it right? Plus 4. So I can just say it is 2 times x plus 9 by 4 whole square minus 91 plus 32 is going to be, that's what we get here. So we get 2 times x plus 9 by 4 whole square we are going to end up as 91 minus 32 would be 59. Yes, 59 over 8. So the coordinate of the vertex is going to be minus 9 by 4 and minus 59 by 8. Be very clear, it is x plus, and I told you the form as ax minus h whole square minus k. Then the vertex is h comma k. So the vertex is minus 9 by 4, but this a is positive. So it will be a parabola like this, where the coordinates of the vertex are negative 9 by 4 and minus 59 by 8, which means this is a minimum. This will give us a minimum value of the function. And this is called a, so therefore this is the minimum point of the function. Minimum point. Minimum y value is negative 59 by 8, which is right from this, the y coordinate, at x equal to minus 9 by 4. In it. That's what he said. Write down the coordinates of the vertex, state whether it is a maximum or a minimum point. 2x squared plus 9x plus 4. And that's what. Is that clear? So taking out the factors to make the x squared coefficient as 1 is very important. And for that, you use both the x squared and the x term, right? And keep the constant outside, and then use the idea that we have done. Isn't it? So this was supposed to be, I think there's a mistake here. It was not supposed to be 91. It's supposed to be 81, isn't it? Yes. So make the corrections, please. 81 over 16, which when we multiply by 2 will give you 81 over 8. So it's going to be basically 81 and not 91. So if it is 81, then we are not going to get 59, we'll get 49. Yes, there is a mistake here. We need to correct that, right? And it is 49 over 8. And therefore, all this will be changed to 49 over 8, please. So this is going to be 49 over 8. So the minimum value of the function is not 59, but minus 49 over 8. And it happens when x is minus 9 over 4. Is it right? 9 over 4 square is 81 over 16. And when I multiply with 2, when I open the brackets, it will become 81 over 8 plus 4. And that's how. So I hope this is clear and how we work towards getting the completed the square form. And once we get the completed the square form, it's very easy to read the vertex and then mention or point out or be very clear about whether it's a maxima or a minima of the function. And that exerts its own application in sketching the curve. And also, as I said, to be able to further find the inverse of the function, and therefore also to see whether the function is a one-to-one function or many-to-one function, which I will be covering in the next series of the lectures coming up shortly. Thank you. Thank you very much.